Good day and good choice to tune into this edition of EHEDG Connects Ask an Expert. Today we're addressing two important questions in the food industry, namely the lifetime economics and the technical collaboration between suppliers and buyers to optimize this lifetime economics of hygienic design. There's an expert with us who knows a lot about these questions. His name is Eric Partington. He is the long-standing chairman of the EHEDG Regional Section UK, and he's with us to give us a few insights in 10 minutes on these topics. Eric, can you give us the most important aspects to optimize the lifetime economics of hygienic design?
The Americans have a lovely phrase. They said that there's never time to do it right, but there's always time to do it again. The most important message I would say is before you start what you want to do, learn, research, find out what is important, look at EHEDG documents which will guide you as to what you should be thinking about. Talk to your suppliers. They can talk to their materials experts. All that information is out there if you just ask for it at the beginning. And then you'll put into place what you need rather than have a go and fix the problems later. The former has got to be the right path. Use all the expertise that's available, plan, prepare properly, and then start manufacturing what it is, the piece of equipment you're trying to design.
That sounds reasonable, but the end user, the client, is not necessarily an expert in materials, for example. So how should he know what to tell his suppliers what he wants?
You're right, he's not an expert in materials or in hygienic design, but his equipment supplier is. The most important thing is that the food business operator is the only person who knows what that food process is going to involve. The temperatures, the pressures, the contact times, the pH of the food. And all this is critical to the choice of materials and to the design of the equipment.
When you're talking about lifetime economics, what do you actually mean?
Total cost over the lifetime of the piece of equipment. And it's very easy to focus on the cost of the material to buy in the first place. But if you have the wrong material, then you will incur greater costs over the lifetime of that piece of equipment. The equipment may suffer from corrosion. That's expensive to replace. It may not be strong enough for what you need, and then to replace it again is expensive. It may be difficult to clean. You may spend more money constantly having to clean a piece of equipment that is not inherently cleanable because it wasn't designed to be, than if you'd spent that time and effort designing it carefully in the first place. And maintenance is also very important. Materials can suffer from surface damage during service life, and a soft material will obviously scratch, for instance, more easily than a hard material, and it might be a cheaper material in the first place, but if it then is going to need surface treatment because it has become a surface that is difficult to clean because it is so scratched, then that's going to cost money that isn't necessary if you choose the right material at the beginning.
Now, Eric, let's move to the equipment supplier. Assuming that he gets a very detailed and accurate description of the goal, the usage of his equipment, can EHEDG help him in this? Because you are also the chairman of the working group Materials and Construction, which actually addresses topics like that, right?
Yes. The answer is read that document. What that document does is not tell you which material to use, but it tells you how materials behave, so that you can anticipate, now that you've been given a good specification from the food business operator, you could say, well, under those circumstances and at that temperature, I need to think about this material. And what that document does, particularly for metallics, for ceramics, for plastics, for elastomers, is give the equipment manufacturer an idea of the little idiosyncrasies of materials, the little tricks that they can play, Many materials can withstand quite a lot of stress. They can stand quite a lot of corrosion. But if you put the two together, you get a phenomenon, not surprisingly, called stress corrosion cracking in stainless steels, which is much more severe than you would anticipate, because it's a combination of stress and corrosion. So that document is intended to be, if you like, a starter to understand how materials behave under certain circumstances. Some synthetics will get softer as the temperature rises. Some will get harder as the temperature rises. If you don't know that, if you don't appreciate those little tricks that those materials have, then you can run into a problem. But if you can read that document, then you know the questions to ask of your material supplier and the information that he's going to have himself to be able to help you.
Now, you're a member of the Brewing Institute, of the Institute of Brewing and Distilling, and you do a lot of consultancy work for this industry. Can you take an example out of that industry that would illustrate what you were saying before?
Yes, I can, without naming names. I was involved recently with the replacement of some pipe work in a brewery. It was carrying what the brewers call liquor, which the rest of us just call water. And in specifying that pipe work many years ago, the brewery only considered what was inside the pipe. And they said, well, material X will be ample for the water that we're putting through that pipe at this temperature and with this chemical makeup. What he forgot was that those same materials can be corroded from the outside, often by the insulation, which is wrapped around the pipe to keep the heat in. And it was this insulation, which was very high in chlorides, which was actually attacking that pipework from the outside. Now, all that pipework has to be replaced. A very expensive operation. And if the right thought processes had happened at the beginning, what is the environment in which this material is going to work? Not just what's inside the pipe, what's outside the pipe, and what can attack that material from either inside or outside. Then those decisions, that process, the way of insulating that pipe and the shielding around the insulation to keep that dry would have been right in the first place and wouldn't have necessitated this rather expensive replacement.
Let's learn from that example and the next time when you think there's never time to do it right in the first place, remember there's always time to do it again, and then it gets expensive. That's what you're saying, Eric Partington. Thank you very much for your insights. And dear viewers, if you have any questions for this expert, just put them in the comment section below. Thank you, Eric.
Thank you, Rob.